All right, so for this first problem, we know that f and g are continuous functions, that f of 5 equals 5, and that the limit as x approaches 5 of 2f of x minus g of x equals 6. So now we're asked to find g of 5. So the first thing for us to note is that because f and g are continuous, this implies that the limit as x approaches 5 of f of x is going to equal f of 5. Because there's nothing weird that can happen. It's not like f of 5 doesn't exist. We know it does because f and g are continuous functions. So we can use this information to then say that the limit as x approaches 5 of 2f of x minus g of x is going to equal 2f of 5 minus g of 5. And we know that this should equal 6 based on what we're told in the problem. So, well, we know that f of 5 equals 5, so this first term is going to become 10 minus g of 5 equals 6. So subtracting 10 from both sides, we will get that negative g of 5 equals negative 4. So then multiplying both sides through by negative 1, we'll get that g of 5 equals 4. So the correct answer is A. So for problem 2, we know that Missy's running a race of 200 meters. She runs the first part in 120 meters at a constant speed of k meters per second, and the last 80 meters at a constant speed of L meters per second. So we want to find her average speed over the entire race. So for the first thing we were going to want to know on the second problem is that average speed is equal to total distance over total time. And that makes sense because speed is like a measurement of distance per some time, like miles per hour. So the first thing we know is that our total distance equals 200 meters. So that's easy. But what we don't know is the total time. So we're going to have to find that. And the easiest way to do this is if we break it up into those two different parts. So for the first part, she ran 120 meters at a speed of k meters per second. And then the second part is going to be her running 80 meters at a constant speed of L meters per second. So what we're going to want to do is we're going to want to use the formula that distance is equal to rate, which I'll use r here, times time, t. So rate would be like our constant speed in this case, so like meters per second. So using this formula, we can rearrange to get that time, t, is going to equal distance over r, our rate. So what that means for us is that for the first part, the time it took her, we'll call this T1, was equal to the distance she ran, which was 120 meters, at k meters per second. So this means that it took her 120 over k seconds to run the first leg of the race. So for the second leg of the race, so for part 2, and we'll call this time 2, well, her distance for this part was 80 meters, and her rate for this part was L meters per second. So it took her 80 over L seconds to run this part. So our total time would be T equals T1 plus T2. So that means that our total time up here would be 120 over k plus 80 over L seconds, which means that the correct answer for us would be, her average speed would be B. So for this third problem, we're told that we have a function f that gives the amount of water in thousands of gallons in a Stillwater water tower t hours after noon on September 17th. Which of the following statements best describes the meaning of f prime of 6.5 equals negative 117? So the first thing to note here is that f is a measurement of volume measured in thousands of gallons. But we're asked to describe what f prime means. So f prime is the derivative of f, which means that we're going to be talking about the slope of f, or the rate of change of f. So this would be the rate at which water is coming in or out of our tank. So two things to note is that we have f prime of 6.5 equals negative 117. So the 6.5 implies that we are 6.5 hours after noon, so that would be at 6:30 p.m. on that same day, so on September 17th. The negative 117 would mean that we are losing, our water tank is losing, or it's draining 117,000 gallons per hour. So it's gallons per hour because our function f is measured in gallons, and then per hour because t is measured in hours. So because of this, we're now going to want to look at which sentence says this. So if we read the first sentence, at exactly 6:30 p.m., so the time's right, on September 17th, water was draining from the tower at an instantaneous rate of 117,000 gallons per hour. And this makes sense, because whenever you're plugging something into your derivative, you're finding an instantaneous rate of change at that point, or at that time, or at that x value, or whatever your function represents. So the correct answer for this one is A. So for problem number 4, we're asked to find the rate of change of each of these graphs f, g, and h, and then rank them based on smallest to largest, or if they're all equal, then they're all equal. So the average rate of change is just the change, or the slope, between the endpoints of our graph. So for us, that just means we'll just use the slope formula. So the slope formula is y1 minus y2 over x1 minus x2 equals m. You might have heard y2 minus y1 or x2 minus x1. They're the same thing. So for us, that's going to become our AF for our first graph is going to become 8 minus 5 over 8 minus 2, which when we reduce becomes 3 over 6, which is 1/2. Similarly, our AG will equal 5 minus 2 over 8 minus 1, which equals 3/7. And our AH will equal 7 minus 3 over 9 minus 2, which equals 4/7. So we're saying that the slope of the lines I originally drew on each of the three graphs is respectively 1/2, 3/7, and 4/7. So now we want to rank these. So the thing to know is that 7, half of 7 would be 3.5. So 3/7 would be our smallest answer. 1/2 would be the next biggest, and then 4/7 would be the biggest, because 4 is bigger than 1/2 and 3/7 is smaller than 1/2. So for us, that means the correct answer is D. So for problem 5 now, we are given a table, and we're told that the function f is continuous on the interval -4 to 2. And we are asked to determine which of these 4 statements are true and false. So the first statement is that f of x equals 0 must have a solution on the interval -1 to 2. So the thing to note about this is that we're really asking about the intermediate value theorem. So what we're going to want to use for this one is to use the intermediate value theorem, we want our endpoints to be above and or below our desired value. So our desired value here is y equals 0, or f of x equals 0. And we want that to happen across our interval -1 to 2. So if we look at our table and think about our interval, so we have the points -1, 0, 1, and 2. So it doesn't really matter what the numbers are necessarily, it more so matters what the sign of the numbers is, so whether they're positive or negative. So if we make our own little table over here for the interval -1 to 2, we get that it's positive, 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 positive. So that means I could theoretically stay above the line y equals 0, or the x-axis, the entire time between -1 and 2. So this statement isn't true. There's no guarantee that I have to cross. We would have to have one of these signs over here be a negative to guarantee some sort of cross. So 1 is out, which means we can also take out solution A. So the next thing we're asked to do is say that the limit as x approaches 0 of f of x equals 1. So the thing to note is that here, if we look at our table, the value of f of 0 is 1. So it seems likely, but we have to be a little bit careful because that doesn't necessarily mean that the limit approaches it. For example, we could have some sort of jump in our graph, and it could have some behavior like this. But we know that our function f is continuous. So because f is continuous, this can't happen. So we know that this is true because f is continuous. So 2 is good. If we look at 3, f of x equals 0 must have at least 2 solutions on the interval -4 to 0. Well, that's back to like what we were talking about earlier with the intermediate value theorem. So we can kind of make our own little table over here where we talk about whether things are negative or positive. So we're going to have -4, -3, -2, -1, and 0. So at -4 we are 0, which is neither plus or minus. Then we are negative, negative, positive, positive, right? So, well, we know we have one solution because we have the solution when x equals -4. That would cause f of x to equal 0. So the question now is, do we have another solution? So immediately after at -4, we go to some negative value because we hit -5 when x equals -3. So then we have to, and then we go down some more when x equals -2, we're at y equals -7, but then we jump way up to +2 when x equals -1. So what that means for us is that we have to have some function that looks something like this. It would touch right here at -4, go down, down, and then up here it jumps up, and it's positive up there. So notice that we have to cross the x-axis, so we do have at least 2 solutions to this. So 3 is true as well. So for problem 4, we're asked to find f of x, we're asked to determine if f of x equals 0 must have exactly one solution on the interval -4 to -2 is a true statement. So from -4 to -2, it does have one solution. We know that because x equals -4 gives us a solution f of x equals 0. But it might not have exactly one solution. It could have more. Because we could have some weird stuff going on. Our function might look something like this. We're at -4, we're here at 0, and then we go up and then down to hit our -3 value, and then back up, and then back down to hit our -2 value. So there's no guarantee that there's exactly one solution, because there could be much, much more. So what we're going to have to do is take out proposition 4 and say that only 2 and 3 are correct. So the correct answer is D.